This episode of Nova Science Now. Could there be life on Mars?
50 meters, standing by for touchdown.
A new mission is underway.
Years of work
to finally touch Mars.
And it's taking a closer look.
So this is the first time it's ever seen by anybody.
And what they found.
This material we think is ice.
Brings us one step closer to a discovery for the ages.
It must be true that life is quite common, and that means we are not alone.
And they say it's all part of the game. Concussions. They're on the rise and taking a huge toll.
I was really out of it. It was definitely scary.
And not easy to diagnose.
They both look completely normal.
But this one's not normal.
So there's something else going on.
This brain surgeon thinks he knows what it is. And he's created a device to protect our kids.
Traumatic brain injury is the #1 cause of death and disability in young people. And 90% of traumatic brain injury is concussion.
Also, a 40-year-old unsolved mystery.
It's absolutely the only one in the world that we know of.
2 prehistoric beasts locked in a fatal embrace.
Normally, the tusks prevent the animals from locking heads.
New forensic techniques break the case.
If there's a suspicious fracture here,
you'll find out what drove these mammoths to fight to the death. All that and more on this episode of Nova Science Now. Hi, I'm Neil deGrasse Tyson, your host of Nova Science Now. A century ago, Percival Lowell gazed up at Mars and imagined a network of canals built by civilized Martians. Of course, he was mistaken. That kind of Martian life was just Lowell's fantasy. But the search for real life on Mars is still going strong, even though now we'd be happy to find microbes or even just organic molecules. Just recently, a new probe landed on Mars, and this one had the best chance yet of discovering whether Mars could have ever supported life.
This is the thrill of space exploration for me. Who knows where it can lead? I mean, it's that unknown. It's that mysteries may be solved, new mysteries created. It's what keeps us going. This is why we do it.
Peter Smith has spent 15 years trying to get to one place. It just so happens to be a couple of 100 million miles away.
Sending a mission to Mars is somewhat like hitting a golf ball across the solar system. We'll see if we got our hole-in-one.
Smith is in charge of Phoenix, the NASA spacecraft that's been making headlines this summer with its amazing findings on the planet Mars. I got to go behind the scenes to see firsthand why everyone's getting so excited. It turns out there's a profound reason.
Well, how many times have you looked up in the sky and wondered, are we alone in the universe?
But hold on. Are we talking Martians? If Hollywood's got it right, we should be finding monsters on Mars. Or maybe it's alien invaders.
Our Martian friend is a carbon-based life form.
Astrobiologists haven't given up on those carbon-based life forms, but they're looking for something considerably smaller. Microbes. Tiny single-celled organisms. Phoenix's destination? The northern polar region of Mars. For a long time, we've known it has an ice cap, made primarily of frozen carbon dioxide, dry ice. But in 2002, we looked deeper. An orbiter called Mars Odyssey detected elements beneath the surface. The one marked blue was big news. It's hydrogen. That's right, the H in H2O. Water is one of the key ingredients for life. But can Phoenix find it on the planet's surface?
Phoenix is going down to investigate. This is the site we've chosen.
The Mars equivalent of northern Alaska. That's where Phoenix is landing. Less than 10 months after liftoff.
4, 3, 2, 1, mark.
We have now entered the atmosphere and are starting to slow down.
For engineers at NASA's Jet Propulsion Lab, this is it.
Constant velocity phase detected. Altitude 27 meters. 20 meters. 50 meters. Standing by for touchdown. Touchdown signal detected. Landing sequence initiated.
A flawless soft landing. Welcome to planet Mars. Time to get to work.
This is our downlink room. The data is piped to this facility right here, and it comes up on this screen. That's where we
So this
see
is the first time it's ever seen by anybody, is on the screen. That's cool.
That's great.
So if anything was crawling around, you all would see it here and now.
It's up to the team members here at the University of Arizona to tell Phoenix what to do.
He's ready.
I'm ready. Let's do it.
All right.
Rick McCloskey is one of them.
Looky here. It's an exact replica of Phoenix, but is it more than a museum piece? What
It's much
what do you
more.
do with it?
Much more than a museum piece.
There we go.
It allows us to test any sequence, any commands that we send to Phoenix on Mars.
The experiments they've got in store for the real lander can be tested here first.
If we make the decision not to keep this scoop, then we can dump it. Of course,
Phoenix is equipped with a stereoscopic imager, a weather station, and to cap it all off, a robotic shovel. On Mars, the lander is sitting in a desert of dirt. But beneath the dirt, there should be a vast ice field. Is it water? Did it ever melt so it could support life?
Phoenix's goal, take a look and see if the water's really there, and to assess habitability. That is, in the past, was the planet able to support life, and did it?
To find out, Phoenix gets digging. In one of its first trenches, it reveals light nuggets beneath the dirt, exposing them to the heat of the sun. After 4 days, lo and behold, the chunks disappear. They've vaporized into the thin, dry Martian atmosphere. The only explanation?
This material we think is ice.
Not just any ice, water ice. For the first time, we've touched water on another planet. This is an enormous step in the search for extraterrestrial life. But microbes need more than water to survive. Phoenix will be combing the soil for nutrients: carbon, nitrogen, sulfur, and phosphorus. The chemical cocktail that is crucial to life as we know it. On board are 2 labs, one that wets samples and another that cooks them to distinguish different chemicals. Pretty cool contraption. You want one? You just have to know where to shop. You can find something pretty similar and a lot cheaper at your local gardening store.
I don't think it's here.
How about a sheet metal warthog?
No.
Zinnias.
Zinnias? No, not zinnias.
When it comes to the red planet, Sam Canavis has a green thumb.
So you work on Mars and you drag me to a gardening center.
Well, yeah. What we're looking for is exactly what we're going to do with Phoenix on Mars. Exactly what gardeners do.
Gardeners, they water their plants, they prune the flowers.
Yeah.
So there's no plants or flowers on Mars.
If you were going to your lawn care store, you might want to know how good your soil was, how well it would support the grass. Exactly the same thing we're looking for in the Martian soil.
Soil test strips.
Soil testing, that's it. I think we found it.
By looking at the soil, you can tell its ability to support life.
Well, let's see it.
According to Canavis, the deserts outside of Tucson have a lot to tell us about Mars.
But isn't there a little problem? Like, it's 110 degrees outside right now. And last I checked on Mars, it was 100 degrees below zero. So what do you mean this is like Mars?
It's like in the fact that it's a desert, and you can have cold deserts and hot deserts.
Mars is the cold kind of desert. Phoenix's postcards home are visions of the planet's north, never before glimpsed. It looks bleak. How could microbes survive in a place this harsh?
So this is a riverbed.
To find out, Canavis has brought me to a naturally formed gully. Is this a realm that could possibly sustain any life? Its chemistry will tell.
Is it like the pregnancy test where there's a plus sign
Very,
and a
very
minus
similar,
sign?
very similar, and in some ways it's an analog to what we're doing on Mars. On Mars, we're using sensors that are electronic that tell us what's there. This uses color to tell us what's there. Ship it in there for 10 seconds. Now we're going to look here and see there is some phosphorus here. This soil is very low in nitrogen and high in potassium. So potassium.
The tests reveal that it's got phosphorus and potassium, nutrients that tiny microbes love. Plus, there's its pH, how acidic the soil is.
Okay, so this tells you that if you got these readings on Mars, that's within the range of microbes that exist here on Earth.
Even in the harshest environments in the world, from Death Valley to Antarctica, you get the same incredible results, the nutrients for life.
Any desert we go to, we look hard enough and we all of a sudden realize there's life there. You look close enough and you find organisms that thrive in this environment.
Will Phoenix find the same kinds of nutrients on Mars? It's time to put Martian soil to the test.
What can you tell now?
The experiment is progressing as expected, but we don't have the scientific results of it yet.
This is going to dribble on and on and on.
For the next 4 hours.
Yeah.
Hearing from Mars takes time. Every message must be relayed via satellites orbiting the planet. They cross paths with Phoenix only a few times a day, so the news just trickles in.
Initial indications say that we have generated as much data as we would expect it to, which means the experiments are going well.
Just waiting. That part was agony. Every second was an hour. It was definitely the longest hour of my life.
I'll wait till it's all down to look at it.
The stakes are high.
There are a lot of things that can go wrong between Earth and the measurement on Mars. Lots of things. A lot of us have worked on this for a decade or more.
A decade of fruition,
10 years of work.
To finally touch Mars.
10 years.
Then,
all right, here we go. There it is. More, it's coming. It's coming.
the first newsflash is that pH reading.
It's all down to look at it.
If it's extreme, that would be toxic to life.
I want a number from 0 to 12, okay?
The surprise is,
It's basic. It's basic.
it's mild. A reading between 8 and 9. And the news just gets better.
Beautiful. Oh, that is gorgeous.
Magnesium and chloride. Sodium and potassium at levels similar to what we got in the desert. The Phoenix mission has established that this Martian soil isn't just nutritious enough for microbes. It could actually sustain plant life.
I think we're building a case for a habitable zone. What we're seeing is there's a rich mixture of nutrients.
That we could actually come to good scientific conclusions from this data and release them to the public and the world. It's almost like a dream come true.
Getting hit in the head is pretty much a guaranteed laugh. In the world of cartoons,
TV shows,
and movies. But in the real world, it's not so funny. And as correspondent John Torres reports, these days, we're finding out that even a seemingly minor head injury can cause a lot more damage than we ever thought.
Go! Cut!
Good, good. Good job, Reed. Good job.
Reed Snyderman is 17. A high school junior, he plays varsity lacrosse, and he's the U.S. Junior Olympic champion in freestyle skiing. It was the last day of spring break in 2008 when his troubles started.
I was at U.S. Nationals at the end of March, and I landed my top air, which was a backflip iron cross. I was really aggressive, like charging it, because I really wanted to go for it, you know? And I ended up just kind of catching my edge and kind of flipping and hitting my head. And then being really bewildered and not really knowing what was going on.
His coach went over to him first and came back to me and said that he thought he was fine, except he might have a mild concussion.
But Reed was not fine at all.
I was really out of it. Everything's out of sync. It was really difficult for my brain to maintain a train of thought. It was definitely scary.
Almost 4 million athletes, boys and girls, suffer concussions every year. Many of them recover quickly, and a bang on the head is often considered just part of the game. You shake it off and get back to the field as soon as possible. But for 20% of patients diagnosed with a concussion, recovery isn't so easy. Because even when it's mild, a concussion is a traumatic brain injury.
If you look at traumatic brain injury, it is the #1 cause of death and disability in young people.
Jam Gajar is a neurosurgeon at Weill Cornell Medical College in New York and an international expert in brain injuries.
90% of traumatic brain injury is concussion. And how many numbers are we talking about? There are millions.
But concussions are difficult to diagnose. They generally don't show up on a standard MRI like the one I'm having now. So even if a patient has symptoms, understanding why is complicated. Take a look at my MRI compared to the MRI of a concussion patient.
It looks normal. They both look completely normal.
But this one's not normal.
The patient has symptoms of mild traumatic brain injury. The neurologist would tell the patient, it looks normal to me, your CAT scan's normal, your MRI's normal. So there's something else going on.
MRIs produce images of gray matter, cells called neurons and their connections, which make up most of the surface of the brain. Gray matter is organized into specific regions, which control functions like memory, speech, movement, and coordination. But a concussion doesn't usually do much damage to the gray matter. So now, neurologists are searching for clues deeper within the brain, in the white matter.
The white matter makes up the sort of cables or connections between the lobes or the sections of the brain.
Those white matter connections are like telephone trunk lines. They bundle nerve cells from different areas of the brain into networks, which work together to produce and regulate thoughts and actions. But if the white matter is damaged by a concussion, the connections could get disrupted, in theory at least. Until recently, though, it was very difficult to see white matter on an MRI.
To be able to really quantify and qualify the integrity of the white matter, you need to go to a specialized sequence like the DTI or diffusion tensor imaging.
DTI, or diffusion tensor imaging, is a new way to bring white matter out of the shadows, using advanced software to get more detailed information from an MRI image.
Correct. When we bring up the DTI, you can really clearly see where the white matter is and where the gray matter is, because on this, white is white, gray matter is gray.
It's not only the color that's important. White matter helps diffuse water through brain cells, and that may be an important clue to what goes wrong in concussions.
And so with the DTI, all we're doing is looking at where water is, pretty much.
So if the water's not flowing well, that tells you there's something.
If you have a leak in the pipe, we're going to be able to pick that up with the DTI. If you compare the left and the right, you can see these two tracks very clearly here. But you can see on this, you have the one on the outside and the one on the inside is disrupted.
One part of the brain's not talking to the other one because it can't make it through that area.
Right.
And that's what causes the impairment they have later on.
That's what we think. That's what our data shows, yes.
Jam Gajar agrees. His theory is that tiny tears in the white matter caused by a concussion disrupt the brain's natural timing, like a telephone conversation gone wrong.
One way for a normal person to feel like somebody with a concussion is to think of a cell phone conversation. Normally when you talk on the cell phone, you talk, the other person talks, you go back and forth, and it's smooth, but then, like my voice right there, you're expecting my voice to come in, it didn't come in, and you got an error signal.
Gajar's theory is that microscopic tears in the white matter cause these error signals. They disrupt communication between different parts of the brain responsible for helping us to pay attention and remember what's going on around us.
There are populations of cells that communicate with each other and produce brain function. If you disrupt the connections between these areas, you disrupt attention and memory.
And please.
To test this idea, I'm participating in an experiment Gajar devised to measure a person's ability to pay attention. This device records how well my eyes stay in sync with a moving target.
So these cameras are watching where my eyes are moving?
Yes.
We picked eye movements in terms of following a predictable target. And you can't drive your eyes in a circle automatically. You have to pay attention to the target when it's going around.
For most people, this test is easy. My eyes follow the target with no break in the cycle. But for someone who has symptoms after a concussion, it's a different story. 10 years ago, artist Ann Schemp suffered a concussion in a car accident. Even after intense therapy, she still has problems with speech, memory, and attention.
The first day I went into my studio, I looked at my materials and I couldn't figure out what I did with them. Like, I would pick up my... Excuse me, I'm having trouble with words.
Words for familiar things don't always come easily.
Like the paint?
The paint, yeah, like I didn't remember what I did with it. Even though I looked around my studio and I could see my current painting that I was working on. So I turned around and I walked out. I'm still 10 years later having a lot of those difficulties.
Put your chin right here. See if you're nice and comfortable. Okay.
When Ann tries the eye tracking test, it's a struggle.
What's happening with her is she's constantly having to start over again. And she's losing her train of thought. So here's a very predictable target. It's going around like this. My brain should be able to know it's going around like this and where the dot's going to be next. A head injury patient is just wobbly all over it. They're trying to synchronize the dot. Their timing is off. And as a consequence, they've got this variability, which is directly proportional to how good their attention is.
Let's go. Go. Good hit. Good hit.
For young athletes, problems with attention after a concussion can go way beyond the playing field.
Definitely during school, I would lose the entire class and I would lose the entire discussion in my classes, and math was impossible for that week. And I'm usually a really strong math student, so it was really strange.
Read, that stick belongs below the shoulders.
Someone who's had a concussion may look like they should be able to participate, but they're not really aware of what they're doing at all. So that's a scary thought.
But the most scary thought is sending a student who's had a concussion back into the game. This can happen because there's no way to objectively diagnose concussions on the sidelines, and young athletes most often don't want to be benched. But what if there were a tool to quickly and accurately assess if a brain injury has taken place? That's Jam Gajar's next goal.
You can see this is...
He's developing a small, portable version of the eye tracking system I tried in the lab.
You put that on.
And help demonstrate how it might work.
So it's like a pair of regular glasses, and I'll cinch it up here a little bit. How does it feel?
Comfortable.
Good? Okay.
The same moving circle is projected directly onto the lens of the specially designed pair of glasses. Then a miniature camera records how well the eyes follow it. It's a quick way to tell if a concussion has taken place, impairing the brain's ability to pay attention to what's happening on the field.
Let's go, let's go!
And that's an essential piece of information, because an athlete who's had one concussion is at high risk for another.
The person who's got poor attention, you don't want to send them back into play. Send them back in, they are unable to pay attention, and they get another injury. You keep on adding those concussions together, then you see things like dementia and so on, later in life.
Gajar's theory is still being tested. But the potential to diagnose concussions quickly and accurately is an appealing idea to Reed's coach.
It would just take all of the risks out of the equation. Something that is able to confirm a trauma to the brain, but takes the conjecture out of everyone's hands and says, this is what we have to do.
6 weeks after his concussion, Reed has made a full recovery. But the experience stays with him every time he heads onto the field or the slopes.
I think a concussion is one of the scariest injuries that you can get. Like, I mean, when you break your arm, you're still you. You still can think. You still can, you know, you can function fine. But when you hurt your brain, even when it's minor, even when it's not major, it's like you're not you for a while, and that's definitely frightening.
It was a hot and steamy night that made a day on the planet Venus seem like paradise. There was a knock at the door. It was a dame. A dame to make Einstein rethink the fabric of his space-time continuum. Her case was intriguing. Two dead bodies, entangled like a pair of bosons in a shared quantum state. No surviving witnesses. The victims were so big, they made a Panthera tigris look like a pussycat. And, as correspondent Leslie Dodson is about to discover, solving this mystery will take a lot of digging.
This vault at the University of Nebraska is packed with the fossils of extinct Ice Age creatures. It's a collection with an unsolved mystery.
But the bone is in pretty good condition underneath all the matrix of the
bone is in
sand.
great shape.
These bones were unearthed on Nebraska's Badlands, home to species of prehistoric elephants known as mammoths, cousins of the famed woolly mammoths that roamed Arctic regions. These mammoths were among the largest of all, towering 13 feet high, with massive bodies weighing up to 10 tons and tusks reaching out nearly 12 feet long. Despite their fearsome size, their teeth exposed them as plant eaters. These were gentle giants, and that makes these particular remains a startling find. Scientists call this tangle of skulls and bones Clash of the Mammoths. Two mammoths locked in a death grip. This discovery is unmatched in the fossil record.
I've never seen or read about two mammoths locked together. It's absolutely the only one in the world that we know of.
So if mammoths were such peaceful creatures, why did these two titans end up entangled in death? The fatal clash took place here on Nebraska's grassy badlands around 12,000 years ago. These grasses extend as far as the eye can see, and they allowed mammoths to thrive and grow to their massive size.
Yeah, pretty good plan.
Not much has changed here since the entangled mammoths met their untimely end, and they would have gone undetected if not for a chance discovery more than 40 years ago.
This is the place. This is the place. That's right.
In 1962, Ben Ferguson was surveying this land for a dam site when he stumbled across some unusually large fossils.
Saw some big bones sticking out of the bank?
He called in a team of scientists, including Mike Voorhees.
We dug forward and found ribs and a nice skull. This was really pretty exciting. Another few days of digging revealed that there were actually 2 complete mammoth skeletons with their tusks tangled up.
They knew it was a spectacular find, but lacking the tools to investigate further, they packed up the bones and stored them.
It's probably a good thing that the wrappings have remained on these skulls for 40 years, because a lot of the techniques that we're going to be using in studying these mammoths simply weren't there in the 1960s.
Now, new advances in forensics may help solve the mystery of how the 2 mammoths died. The first step is understanding mammoth behavior. Unfortunately, the last mammoths died after the Ice Age, so we can't observe them, but we can study their modern relatives, elephants. So, Mike, what do we have here?
These are skeletons of modern-day elephants. Of course, elephants are the biggest living land animals. Compare these guys with that monster. That is a mammoth.
So what clues can elephants give us about why 2 male mammoths would fight to the death?
Well, normally elephants are very peaceful animals, but it turns out there's one point in the life of a male elephant that they can get violent. They go into a period called must, which is a hormone-driven rage, and they can fight. It doesn't really reach a climax until they're in their 30s or 40s. But I've never read or heard about 2 males actually killing each other.
Is this what happened to the entangled mammoths?
You'd have this other piece.
To help solve the mystery, Voorhees turns to Dan Fisher, a forensic paleontologist who sees tusks as a window into mammoth life. Fisher extracts samples from tusks to detect the age, nutrition, and behavior of mammoths.
Tusks keep growing and growing and growing throughout the life of the animal. Tusks are essentially formed as a stack of cones, like ice cream cones. The cones out at the tip are those formed early in life, and the end of life is represented back at the base.
To analyze tusks, Fisher performs his unique brand of dental surgery, carefully boring small holes and grooves to outline his sample. Fisher uses acrylic polymers to stabilize the fragile ivory, and then extracts small cubes of mammoth tusk. He'll repeat this process all along the length of the tusk. Then, he'll use the samples to figure out how old the mammoths were, to see if they were mature enough to display the hormonal rage brought about by must.
The darkest lines there are weeks, and the light lines in between are individual days of the animal's life.
And do we know how old this animal is?
This animal was about 40 or so when it died.
So the 2 mammoths were the right age, mature males who could experience the rage of must. Now, can Fisher prove their fatal battle took place in the spring during mating season when must occurs? Detecting when the fight happened requires microsurgery. Fisher's team carefully collects powder from about a month's worth of growth lines. Tusks contain a chemical record of what the animals consumed, season by season. Even after thousands of years, remnants of oxygen from their water and carbon from the green plants that made up their diet can be picked up in a chemical process. Dan, what are the results here?
Well, these values rise in summer, lower in winter, and then at the end of life, we've got the end of winter, the beginning of spring, just when they would be going into their mating season.
But even if they died in the spring mating season, did their bodies contain the testosterone overload from must to make them fight? One more test. The growth rings reveal seasonal eating patterns.
When they're thicker, it means the animal was eating more, was healthier, growing its tusk faster. When they're thinner, it means there was less to eat, and the tusk was growing more slowly.
But just before the mammoths died, the layers abruptly go thin, unexpected for hardy spring appetites.
But it's exactly what you expect in a mature must male. The hormones trigger a physiological syndrome that involves focusing on mating, focusing on competition. Who cares about eating?
Fisher's evidence suggests the fighting mammoths were mature adults who engaged in battle during the spring mating season in a fit of hormonal rage. Mystery solved. Or is it?
I'm not sure. Normally when two animals are fighting, you've got a winner and a loser.
When modern elephants clash, fights often last half a day or more. And routinely, the more aggressive bull emerges a clear winner and the loser skulks away. So why did these two mammoths fight to the death? Voorhees suspects they're missing a piece of evidence. Recently, curators have been cleaning and restoring the fragile remains, stripping plaster and gummy shellac coated on decades ago. Suddenly, they've unmasked a startling clue.
There's about a 1 foot section of bone missing here from the cheek of this mammoth, and a suspicious fracture here.
The form of this fracture is really only consistent with impact from the side, and that would be consistent with a tusk battle where somebody gets a left hook.
That's right, and a lucky punch on the cheek.
Right.
But how can one good punch possibly result in two dead mammoths?
Normally, the tusks prevent the animals from locking heads. But in the case of these two mammoths, each of them had one normal tusk and a stub. That made it possible for each animal to use the single tusk as a spear for goring the other guy.
After repeated attacks, one tusk impales an eye. Then a fluke collision. The long tusks clamp over the skulls, locking them together. Why can't they simply pull apart? Voorhees has a theory, but to test it, he has to visit the scene of the battle. Normally this area is bone dry, but the day our mammoths fought, it's spring. That means rain, and that changes everything.
My opinion is that when the Badlands are wet, you can't stand, you can't drive, you can't walk around.
The slick turf sent the bulls crashing to the ground, but how they fell sealed their fate.
The tusks overlapped the heads and the bodies, and they kept the other guy from getting up. They fell in such a way that each of them had basically the full weight of the other one pressing down on him by means of the tusk.
Their broken tusks are locked in a death grip. Undoubtedly exhausted, the mammoths died in this position, locked together for all time. The 12,000-year-old mystery is finally solved.
Every once in a while in science, someone has an idea that changes everything. Judah Folkman, who died this past year, wanted to stop cancer in its tracks, but his quest ultimately went much further. In a past NOVA documentary, we called him a cancer warrior. Correspondent Chad Cohn reports on where Judah Folkman's battle has led.
Judah Folkman often said, "Science takes you where you imagine it."
Dr. Folkman's entire career was really testimony to this concept of the power of an idea. He not only had the intellect to be able to understand a problem, but he had the courage to really focus on huge problems and huge questions whose answers would have a profound effect on people's lives.
In 1967, Dr. Folkman was appointed the youngest chief of surgery in the history of Children's Hospital in Boston. His surgical skills were legendary, but it was cancer that captured his attention.
He would operate on children with tumors, and he noticed that the tumors were red. Now, other people noticed that tumors were red, and they thought they were inflamed. And what he realized was the red was blood vessels.
While others dismissed those blood vessels, Dr. Folkman began a lifelong quest to understand them. By 1971, he wrote his ideas down in a now famous paper. In it, he described angiogenesis, which means new blood vessel growth. He suggested that cancer cannot grow without blood vessels, and that tumors secrete a mystery factor, shown here in blue, that travels to the nearest blood vessel and stimulates angiogenesis. With a network of new blood vessels, the tumor gets the nourishment it needs to grow.
Then he said, if you could eliminate the blood vessels, you would shrink the tumor. It was a revolutionary idea because the notion had been that the only thing that mattered was the tumor cells. And now here's someone saying, we can start to treat a tumor by targeting a whole different cell type.
Treating cancer by stopping blood vessel growth was a revolutionary idea. Unfortunately, few colleagues believed him.
One very distinguished pathologist said, angiogenesis is just inflammation. These are inflammatory products, which means they're non-specific dirt. And he said he's working on dirt.
To quiet his critics, he and a colleague devised an ingenious experiment to prove that tumors do secrete a factor that recruits new blood vessels. They used a rabbit cornea. It's a crystal clear dome that covers the eye, and blood vessels never grow there. They sandwiched a tiny piece of tumor in the middle of the cornea. After a couple of days, new blood vessels emerged. They crawled up the cornea straight toward the tumor. Within 2 weeks, the tumor grew 16,000 times its original size. When they removed the tumor, the blood vessels regressed and disappeared. But even this didn't convince the critics.
If you say, I found angiogenesis, your colleagues are going to say, what's the mechanism? You say there are factors, they're going to say, show us the factors.
It took 10 long years to find the proof he needed. Finally, in 1984, Dr. Folkman's team isolated a single protein that caused tumors to recruit their own blood supply. It was a major turning point.
Every once in a while, there is a tremendous finding, and you realize for the first time in your life that you know something that hour or that day that nobody else in history has ever known, and you can understand something how nature works. That doesn't happen to many scientists, and if it does, it's a blessing, and if it happens more than twice, it's a miracle. And when it happens, it's a very big high.
But Dr. Folkman's work was not done.
He wasn't going to be satisfied understanding angiogenesis. He had to take angiogenesis to a treatment for cancer.
The Holy Grail was now to find a molecule or drug that turned angiogenesis off. In essence, treating cancer by cutting off its food supply. They looked everywhere. In fungus, in existing drugs, and in the body itself. Slowly but surely, anti-angiogenesis drugs were discovered throughout the 1990s in laboratories around the world. While it's still too soon to evaluate the clinical success of these first-generation drugs, today the field of angiogenesis is growing rapidly. But the man who pioneered it is gone. Early this year, en route to a scientific conference, Dr. Folkman's heart suddenly stopped. He died at the age of 74.
I think there is absolutely no overstating the magnitude of the loss. He was a visionary. He was a pioneer who established the field of angiogenesis research and, educated the next generation of scientists. He was a committed mentor. He was a dedicated and very humble role model.
Dr. Folkman left his colleagues a precious gift. Now protected under plexiglass, it's a handwritten list of his final ideas and a peek into the future of angiogenesis research, which now extends well beyond cancer. Abnormal blood vessels turn out to be an underlying factor in more than 60 diseases, including an eye disease that afflicts millions of people around the world. Gloria Cohen is one of them. A couple of years ago, she was diagnosed with a devastating form of macular degeneration and was rapidly going blind.
I was absolutely shocked and dismayed, and all the things that I couldn't do anymore came into my mind. Thought about the driving. I need to drive. I'm one that tries not to be hysterical, but I guess I couldn't hide it.
In Gloria's form of macular degeneration, abnormal blood vessels start growing in the back of the eye. They leak blood and fluid, which damages the retina. No effective treatment was available until Joan Miller and a team working with Dr. Folkman found a surprising connection with cancer. A protein called VEGF that stimulates blood vessels in many cancers also turned out to be active in macular degeneration. It was a stroke of luck, because a VEGF blocker, already in development for cancer, was adapted for use in the eye. After 3 injections, the blood vessels in Gloria's left eye not only disappeared, but much of the damage was reversed. Today, Gloria is driving with confidence and 20/20 vision. But only about a third of patients are seeing results as dramatic as Gloria's. To help the rest, early detection is key.
We're hoping to be able to do a blood or a urine test where you measure a marker that suggests that abnormal blood vessels are going to grow, and you can come in with a treatment and stop them before they cause any damage or any vision loss in a patient.
Detecting abnormal blood vessel growth in its earliest stages was at the heart of Dr. Folkman's ultimate goal: to reduce cancer from a devastating diagnosis to a manageable disease. And that's what his colleague, Marcia Moses, is working on now. She's looking for early warning signs that cancer is growing. Inside her laboratory freezer are 8,000 samples of urine. Some from healthy donors, the rest from cancer patients. They're putting the urine through a series of tests. They're not looking for cancer cells, but for proteins associated with the onset of abnormal blood vessel growth. If they are in these drops of urine, the liquid in the well will turn bright yellow.
The darker yellow ones either have cancer or are at risk of developing cancer, and the cancer could range from early disease to metastatic disease, and we would predict...
If large-scale studies now underway confirm the lab results, this work may lead to a simple urine test that could detect cancer long before current methods. Just as Dr. Folkman envisioned many years ago.
It's very possible in the future that we will have a diagnostic test that says you're showing up with cancer and you'll get a mild angiogenesis inhibitor for 10 years until the test goes down.
I think the path is very clear. We've had the benefit and the inspiration of working with Dr. Folkman. And I just think we have to have the intellectual courage, as he did, to carry out that legacy. And we're going to work very hard to do that.
And now, a birthday greeting from me to NASA. Happy birthday, NASA. Did you know we're the same age? In the first week of October 1958, you were born by an act of Congress, while I was born of my mother in the East Bronx. I was 3 when your first astronaut orbited the Earth. I was 10 when you landed on the moon. And I was 14 when you stopped going to the moon altogether. I was happy for you and for America, but the thrill of the journey, so vibrant in others, felt out of my reach. I knew that my skin color was much too dark for you to picture me as part of this epic adventure. Of course, I shouldn't blame you for society's woes. Your conduct was a symptom of America's habits, not a cause. But I want you to know that I became an astrophysicist in spite of your achievements in space, rather than because of them. You've come a long way, though. Today, you look much more like America, from your senior level managers to your most decorated astronauts. And when you're at your best, nothing on Earth inspires the dreams of a nation the way you do. All in the greatest quest there ever was, the search for our place in the universe. NASA, as we both enjoy our 50th trip around the sun, I look forward to seeing you back on the moon. But don't stop there. Mars beckons, as do destinations beyond. And that is my cosmic perspective. And now, we'd like to hear your perspective on Nova Science Now. Log on to our website and tell us what you think. You can watch any of these stories again, or download audio and video podcasts, take our Nova Science Now quiz, hear from experts, and much more. Find us at pbs.org. That's our show. We'll see you next time.
Educators and other educational institutions can order this NOVA program for $24.95 plus shipping and handling by calling WGBH Boston Video at 1-800-255-9424. NOVA is a production of WGBH Boston.